guest this week is Eric Gratz, co-founder and CTO of Ascend Elements. Ascend has built America's first factory to produce battery precursor material, or pCAM, using material from recycling lithium-ion batteries. China dominates production of pCAM, with 90% of current production capacity, according to Benchmark's Precursor cathode active material assessment. Ascend was founded in 2015, based on work done by Gratz and others at Worcester Polytechnic Institute. The company says it can make pCAM and cathode active materials more efficiently than current methods and with a lower carbon footprint. In this interview, which was filmed at the end of last year, Gratz talks about when its Kentucky pCAM facility will start, why the company's production of lithium has a lower carbon footprint, dealing with a price downturn, and much more. Well, Eric, thanks so much for joining me. Ascend Elements recently announced you would begin producing around 3,000 tons of lithium carbonate from used lithium-ion batteries in Georgia next year. Can you explain the significance of this and how much lithium you expect to be producing this decade?
Yeah, so we're very excited that our recycled lithium carbonate product is going to market here, really next year. To our knowledge, this is the second source of lithium carbonate in the U.S. and the first opened, since the 90s. So we think this is a significant milestone for the industry, this is the first line in Covington, Georgia, but we have plans to add capacity using the same technology in our Apex site. So total production over the next decade, will be up around 10 kilotons of lithium carbonate per year. So fully ramped, but that'll ramp over the next few years.
And I presume this lithium is technical grade and needs to be converted to battery grade. Will that be done within the US as well?
Yeah, so that is a technical grade product. Our first contract is for with the North American refiner.
And you said the process is 86% lower greenhouse gas emissions and even 37% less carbon intensive than lithium brine, which is very impressive given that they just use the sun to evaporate. Where does that come from, that lower carbon footprint?
It becomes lithium in batteries is already very concentrated, so it's much more concentrated than brines, and so that's like one major component in our favor. And then we also have a much shorter global supply chain. We're not shipping the material all over the world to essentially make it into a battery grade and then back into a battery. It's essentially staying within North America, from end of life battery back into new battery.
And in terms of producing minerals like lithium, will you do that alongside producing precursor materials and cathode, or is your focus mostly on precursor and cathode?
The focus for Ascend Elements right now is on precursor and lithium. So to be a battery materials supplier, we are looking at ways to enter the cathode market space, but we are building out our facility in Hopkinsville, Kentucky, to make precursor, and then we have the lithium recovery now in Georgia.
Got it. And in terms of your facility, the precursor facility in Kentucky, what's the status of that? Because I know it was originally going to start in the first quarter of next year, and I think now it's later in the year. Is that right?
Yeah. We plan to start, essentially by end of next year. So we're, I think, still moving along, and we'll still be, North America's, full scale hydro refiner, North America's first pCAM supplier at scale.
And what have you learned building the facility in terms of competing on costs with China, who is obviously the dominant producer? Can you compete?
Yeah, so our capex is certainly higher than China, and this is also our first facility. I think the next facility for us will be much cheaper. We have learned a lot of lessons along the way. So China is very cheap, especially on the capex end. but we're very competitive on sort of our chemical cost, our raw material cost, and energy. They're more competitive on labor and just the capex cost.
So what about trucking in all this recycled material? What are the logistics and costs of that look like?
Yeah. So, well, we're really trucking the material, into our Covington, Georgia facility, where we'll make you know, the lithium and then sort of the delithiated nickel cobalt ore from the spent batteries, which we'll truck to Hopkinsville, Kentucky initially, and in the future we'll go via rail. But those facilities are not so far away. It's about a 5-hour drive. So I think it's a very reasonable and condensed supply chain.
And in terms of precursor material, you tailor it for specific battery chemistries. What are you seeing in the US market in terms of where cathode chemistries are going?
Yeah, it's a pretty interesting space right now. I think a few years ago there was a really high push or strong push to increase the nickel content, to increase the energy density, and those products are still around, and people are looking at how can we like eliminate cobalt in those very high nickel materials, but we're not necessarily seeing those. We're kind of reaching the sort of the practical limit with those technologies. We maybe squeeze 1 or 2 more % nickel in and 1 or 2 more % cobalt out, but we're really reaching the practical limit there. So we're seeing a lot of movement in the mid nickel space and lowering the cobalt, increasing the manganese, and also increasing the voltage that the cell can run at with those materials. And I think that's a really interesting way to make a lower cost product that still has a very high energy density. That's 85% of the energy density, in some cases maybe 90% of the energy density of a very high nickel product, but is only is using 50 or 60% nickel as opposed to more than 90. So that's kind of an interesting direction the market's going in.
And so do you see that becoming more dominant in the US then?
Yeah. Especially as we see more EV adoption. So if you want like a, maybe not, the most expensive sedan out there, but you still want to get very good range in the US market in a sedan at a reasonable price. I think this is an excellent technology for those applications.
And you obviously focus on NMC, nickel, manganese, cobalt chemistries. What do you think about the extraordinary rise of lithium iron phosphate, LFP, that we've seen in China? Do you think the US market is going to adopt LFP chemistries?
Oh, yeah. I mean, 100% there will be some LFP adoption. It's just a matter of how much. And so, we our sort of core technologies around NMC materials. We've looked at LFP recycling. Frankly, right now there's just not volumes. So LFP is coming, but I don't know. I kind of need a crystal ball to decide when the right time for us would be to invest in LFP recycling. It's a little hard to predict.
So no plans yet.
Yeah.
And I just wonder if you could talk about your technology, the secret sauce. You discovered this right as a postdoctoral student at Worcester Polytechnic University, where you worked with Yan Wang to develop the first patent. Can you talk about how it works and what's different about it?
Yeah, so it's a hydrometallurgical process. So we dissolve the spent cathode materials in acid in the sort of traditional process to recycle lithium-ion batteries via hydromet is solvent extraction. So you extract the cobalt, you extract the nickel, you extract the manganese with an organic solvent, and then you crystallize those materials to make nickel sulfate, cobalt sulfate, manganese sulfate. For us, we don't separate the nickel, manganese, and cobalt with our technology, which we call hydro-to-cathode. We remove the impurities from that solution. So we get a solution of nickel, manganese, and cobalt. We remove the impurities, and then we'll like adjust the ratio to the target output. So if we have, 811 coming in and we want 955 going out, we'll add some nickel to get the right amount of nickel, manganese, and cobalt. And then we do a precursor synthesis reaction just like you would with virgin material.
Got it. And in terms of the precursors you're producing, do they have to be mixed with fresh materials to meet the performance requirements of some applications?
No, we don't have to mix them with virgin material to meet the performance requirement, though we are always mixing with some virgin material just to balance and get the right ratio of nickel, manganese, and cobalt.
So I think very early on, when you were doing your original work as a PhD, you discovered the performance. The performance was good of this material. What can you talk a bit about what is the performance benefits of this process?
Yeah, so that particular material, so I think there's a paper in Joule where we show the cycle life being significantly longer for the recycled material versus a standard virgin CAM source, and then they have very similar energy density. That particular material had to do with the morphology and how we made the particle that basically prevented the particle from cracking, so it would have longer cycle life.
It's something you can replicate today, right? On other cathodes.
Yeah. So we have another one of our, we do have a CAM contract, and one of the reasons for that is because we have made a very long cycle life CAM material in the mid nickel space where we're getting, thousands of cycles.
And you've been working with Freudenberger e-power. This is for heavy duty applications. Can you talk about how you're tailoring the material for them in terms of requirements, performance requirements?
Yeah, they're in the heavy duty space, they're very they're really focused on cycle life and safety. So we're optimizing the CAM material, for those aspects. So I think that the energy density is very good, but you can find higher energy density materials of the same, formulation. I don't think you can find, material of the same formulation that has the same cycle life and safety. So that's the tailoring we've done for them.
So you can improve cycle life and safety in your process.
Yeah,
that's interesting. Just in terms of recycling, I mean, according to our database, you've got the largest battery recycling operating capacity. Are you trading the black mass, or are you refining all this to produce precursors?
Yeah, so right now, we're extracting the lithium and then selling that delithiated product. I call it like a nickel cobalt ore. You can call it it doesn't really have a market name for a black mass that's been delithiated. So I just call it, but so we sell that. And then, in the future, when Apex is up and running, we'll refine the black mass ourselves.
And in terms of, just the overall market, I mean, are you concerned the slowdown in EV sales and battery producers pulling back, that there's going to be less process scrap available in the US going forward?
I'm not so concerned on the near term, scrap. Where we have a lot of batteries to recycle, and trucks showing up every day. So I do, there is a concern on the just the raw materials cost and the competitiveness for our outputs. That's where slowdowns in EV adoption hit us harder, I would say.
Yeah. So current market prices, we've obviously seen nickel fall, cobalt fall, lithium fall. I mean, can you be competitive at these low prices?
Yeah, we're competitive at these prices, and we make money, but it's harder to fund capacity expansion, and so it's this tricky thing where the market is slowed down right now, but everyone knows it is still increasing every year, regardless of what you read. And so capacity, will eventually need to increase as well to support it. And so that's what we have to, I think our investors are well aligned and aware of that, but obviously also, higher pricing helps.
Yes. So you mentioned trucks coming every day with batteries. I mean, where's all that coming from?
Yeah.
Where are those batteries coming from then?
All over the United States. So I think, as you said, we have, one of the largest or the largest operating plant. So it's coming from literally probably every state.
Interesting. And is there anything you think regulations should do in terms of black mass or preventing that being exported? Anything that needs to happen?
Oh, that's a tricky one. I don't know if I feel comfortable weighing in on that right now. there's I think there's positives and negatives to that. So I'm gonna hold my comments on that for now.
Okay, no problem. Just in terms of President Donald Trump coming in, I mean, are you concerned that the funding available through Department of Energy, the sort of support through the Inflation Reduction Act, other policies, are you worried about all that getting wound back and the knock-on impact?
I mean, certainly, I think I support the Inflation Reduction Act, and I hope that doesn't get rolled back. I think it's a little bit up in the air, remains to be seen. I don't think it's a guarantee that it will, but it is on the table. So that will impact, I think, as you guys have reported, that will impact adoption of EVs, and so that would be challenging for us, but I don't necessarily view it as like an existential crisis to the business. And then otherwise, I would say right now, generally, there's a lot of fear amongst with the tariffs amongst sort of the battery material suppliers, since they're all essentially outside of the U.S. Except for us and one or two others. So we'll kind of see how that shakes out here over so it may end up being a net neutral or a slight positive. I don't quite know. We kind of have to see how it shakes out.
Yeah, I was wondering whether the tariffs would be good for you, or if you're still using some sort of virgin material, whether actually you need imports as well.
Yeah, I mean, the majority will be recycled. We'll have some, imports that will be at a higher price, but the majority of the material will be recycled. So if our competitors have tariffs on 100% of the material, that should in theory be a net positive for us.
And in terms of future capacity expansions, have you sort of dialed back at all given this environment, or are you still on track?
Yeah, we haven't. The only thing we've dialed back or pushed out is timelines. So we the first 10 KTA of pCAM from Hopkinsville is 1 year, so 1 year to 9 months later than originally planned, and then we have a follow-on 10 KTA to follow that, and so that is essentially getting pushed out by the same increment of time.
Yeah, and in terms of Europe, you have a joint venture in Poland, and I think you're planning one in Germany.
Yeah,
will the German plant still go ahead then?
Yeah, we haven't seen any reason to delay our activities in Europe at the moment. So, we had the JV in Poland is operational, and we're doing those sort of like engineer level studies for our expansion there.
And that material from Europe, will it come to the US then, or will it stay in Europe?
So right now we're selling that material, I'd say, essentially on a global market. We may choose to refine that material at our Apex facility when it is up and operational, and sort of if we're truly running, if Apex is running at 100% capacity, we may need it. If it's not, then we probably don't. So it's just going to be, we'll flex that material as needed into the different verticals in the supply chain.
Interesting. And just on the graphite recycling, you recently announced, or the Department of Energy recently announced a deal to support graphite recycling. I mean, again, given the low prices at the moment, is it economic to do that?
Well, graphite, I think, is actually relatively interesting because of China's export ban on graphite. So, while prices, I would say, are relatively low, um, at the moment, there's a fear premium for domestic production. So, um, I think, um, and that business is kind of unique because essentially 100% anode material was made in China, or not whatever the exact number, 90, but but and with the export restriction very recently going in place, it's kind of left people scrambling in the supply chain.
So I like the word fair premium. So people would be willing to pay more
Yeah,
for US supply,
yeah,
right?
yeah, yeah,
Yeah. Just in terms of other automakers, you
yeah.
have a pCAM agreement or precursor agreement with an unnamed automaker. Are you talking to more automakers? Are you seeing interest by them in securing supply?
Yeah, I mean, there's no automaker that's in production in EVs that we're not either doing business with or having conversations with. So we just a lot of the deals, like especially if it's just recycling contract, we're not going public with that. But we work or have conversations with all of the major players.
Got it. And in terms of pricing these products, because it is such a China-dominated market, how do you work out the pricing for precursor material that you're selling?
Yeah, I mean we're competed against sort of the fully landed cost of the precursor material.
And you could be competitive against that cost.
Yeah. At the fully landed cost, yeah. So if we were competing against the price that China is selling for it in China, that would be a tough position for us.
And then in terms of the black mass market, I mean, do you see pricing developing in the US for that, a market developing for that?
Yeah, I mean most of I would say there's not really a scaled production, a scaled refiner in the US. Um, at the moment, I think our Apex facility will be the first. Um, so, you know, plenty of black mass is made in the US, but it's all exported. So that's why I say it's, kind of when you talk about export restrictions on black mass, there are some, near term downsides.
Okay, just finally, just to be clear then, because you release these figures that I think that even the pCAM process is 90% lower greenhouse gas emissions. Could you just talk about how you get to such a high figure? Is it that in China it's because they're using coal-fired power, or is it your process cuts out those intermediate steps?
Yeah, it's a combination of things. So it's not just one thing. So one, I would say the biggest reason is cutting out process steps, as you say. Um, uh, battery is simply higher. It's the most concentrated nickel mine in the world. Um, but then actually, like the traditional hydro process has a relatively high carbon footprint because of the organic solvents and all of the chemicals needed to do the sort of pH adjustments associated with those. Um, so that's the biggest contributor. Um, uh, Another major contributor is we're located in the TVA power grid, which is one of the cleanest grids in the United States, has a lot of hydro power. So our energy is very clean. And then the third biggest is, again, we're not shipping these materials all over the world in terms of, pCAM. We're getting batteries in the United States, refining it in the United States, and our end customers in the United States. So we have a very consolidated supply chain. And that 90% does assume that we transition, that will be when we've fully transitioned to rail between our two facilities. Which is, in our plan.
All right. Well, thanks so much, Eric. That's really helpful. Thanks for your time.
Yeah.